Okay, class, we are going to look at the definition, the formal definition of absolute value function. So far, what we have looked at is the basic definition of absolute value, which represents the distance a number is from 0. So for example, the absolute value of 5, if you count the squares to 0, you notice the distance is 5. Whereas the absolute value of -5, the distance -5 is from 0 is also 5 units. 1, 2, 3, 4, 5. So that's the basic definition of absolute value. Now we're going to look at a more formal one. And this definition is going to be very important when we solve absolute value equations. Okay, so here's the definition. The absolute value of x is equal to x if x is greater than or equal to 0. The absolute value of x is equal to -x if x is less than 0. So this is what's known as a piecewise function. If I can spell piecewise. So here we have x, and on a graph that would be the positive portion of our function, starting at our vertex of 0, starting at 0. And if you think about a line with a slope of 1, rise 1, run 1, rise 1, run 1, starting at 0, 0. And this would be the other side of our absolute value function, our other line with a negative slope. And so these two pieces together create two lines that meet at 0 at the vertex. Okay, so let's go into the definition. So let's use our examples below. So let's say that x is positive, okay, 5. So we're going to look at this piece. Since x is 5, 5 is greater than or equal to 0, so this is what we're going to use. So basically, if x is 5, inside the absolute value bars, then the answer will be 5. It's the same, as we can see right here. The absolute value of 5 is 5. It's the same. Okay? So if we have positive numbers, including 0, the absolute value of any of these numbers is going to be the same. Pretty straightforward, right? Okay, so here's the kind of confusing part. If x is negative, for example right here, -5, that is a number that is less than 0. So we're going to use this algorithm right here to determine our answer. So pay very close attention. If x is -5, we're going to use this algorithm right here. So to get the answer, we would have negative, and what did we say x was? -5, right? -5. And so that's how we get an answer of +5. So our negative x values, that's the numbers to the left of 0, they get put into this algorithm, okay? And so we end up having a negative number, which makes a positive number. So this is going to be a very important definition that we are going to be using going forward. Let's do a couple examples. Let's do the absolute value of -3. Okay? So since x is negative 3, we would use this. This tells us which algorithm to use. So we're going to plug negative 3 in for x. So we would have negative, plugging in the negative 3, and then we would get our answer, which is 3. Okay, let's try another one. Let's do the absolute value of 10. Okay, so since 10 is positive and it's greater than 0, we use this algorithm here, or this is the condition. This is the algorithm. It's going to be the same. So if x is 10, then our answer is 10. Okay, I hope that makes sense to you. This is the formal definition of absolute value. Very important to understand and be able to use. See you guys in class tomorrow. Hope you're having a good night.